good morning. It is my great pleasure to extend my warm welcome to everyone gathered here for this special occasion at KV Sridhar Hall in Matrushri Engineering College. We are delighted to host this one-day outreach program on chip designing and computational intelligence, organized under the esteemed aegis of the India Semiconductor Mission. We are honored to have with us an array of distinguished guests, esteemed speakers, and enthusiastic participants. Your presence today is a testament to the importance of this event and the potential it holds in fostering the event, innovation, and excellence in the field of electronics and communication engineering. I would like to begin by extending a heartfelt welcome to our chief guest and speaker of the today, Dr. D.K. Yadav, Professor and Head, CSE Department, NIT Jamshedpur, and President of ISVE Ranchi. Dr. Vijay Nath, Assistant Professor, BIT Mesera, and General Chair, ISVE Ranchi. K.K. Thakur, and our respected Principal and HOD of ECE Department, and Sri Bala Ma'am, Associate Professor, ECE Department. We are grateful for your time and expertise you will share with us today. Your contributions are highly anticipated and valued. A special welcome to our students, particularly from the sixth semester. Your enthusiasm and eagerness to learn about the driving forces behind this event are appreciated. We hope that today's session inspire you and provide you with valuable insights into the latest advancements in chip designing and computational intelligence. Today's program includes a series of insightful addresses, technical talks, and exchange of memorandum of understanding, and all aimed at enriching our knowledge and fostering contributions in the semiconductor field. To start our proceedings, we would like to have a lighting of the lamp, followed by an invocation song, setting a positive and auspicious tone of the day. I would like to welcome all the dignitaries to light the lamp. To call Mehak from Triply Department for the invocation song.
गणनायकाय गणदैवताय गणाध्यक्षाय धीमहि गुणशरीराय गुणमण्डिताय गुणेशानाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीशनाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीशनाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि गानचतुराय गानप्राणाय गानपरात्मने गानोत्सुकाय गानमत्ताय गानोत्सुकमनसे गुरुपूजिताय गुरुदैवताय गुरुकुलस्थायिने गुरुविक्रमाय गुह्यप्रवराय गुरवे गुरगुणवे गुरुदैत्यकलक्षेत्रे गुरुधर्मसराराध्याय गुरुपुत्रपरित्रात्रे गुरुपाखण्डखण्डकाय गीतसाराय गीततत्त्वाय गीतगोत्राय धीमहि गूढगुल्फाय गन्धमत्ताय गोजयकराय धीमहि
Dibala Ma'am, Associate Professor of ECE Department for a welcome address. Honorable guests, esteemed colleagues, and my dear students. On and along with the inauguration of the Indian Society for VLSI Education Zonal Center at Mathrusri Engineering College under the aegis of India Semiconductor Mission, which is organized by Department of Electronics and Communication Engineering. The main objective of this program is to inaugurate the ISVE Zonal Center for Telangana, Andhra Pradesh and Tamil Nadu states at Mathrusri Engineering College. And this program provides a platform to spread the awareness on VLSI education and dedicated to exploring the advancements and the numerous applications in the field of VLSI. We are delighted to have you all here today, and your presence shows the commitment, dedication in making a difference and striving towards getting acquainted with the industry needs and the state-of-the-art technology. I would like to extend a special welcome to our chief guest, Dr. D.K. Yadav sir, Professor, NIT Jamshedpur and President ISVE Ranchi, whose contribution towards the ISVE professional body activities and the research in VLSI is commendable. Many events are conducted under this professional body, and this is going to be one more edition. We welcome you, sir. Warm welcome to Dr. Vijayanath, Associate Professor, BIT Mesra and General Chair ISVE. His research activities in the field of VLSI are appreciable. Sir, your presence and your expert lecture in this outreach program is definitely apt for this event. Hope the students will gain a lot of insight into its applications and advancements. Today, we also have a special invitee, SH.K.K. Thakur, former CGMT, BSNL Jharkhand, and sir would enlighten about ISVE and the advantages with the ISVE membership. We welcome you, sir. Let's make the most of this opportunity to learn, share, and grow together. And I hope the students will gain a lot and enjoy the program. Now, I would call upon Dr. N. Srinivas Rao, who is the Zonal Coordinator, to address the gathering.
Good morning, everybody. Respected dignitaries on the dais, off the dais, HODs, invitees, coordinators of this program, and student members, invitees. Very warm welcome to you all for this program. This is a long pending issue. We made a request 3 years back to inaugurate open a center at Hyderabad. Vijayanath sir's active support from our college and MESR, few members already membership under ISVE, and we submitted various papers in various international conferences, and we got best paper award also, that is for my team, and this is a platform where you can learn various advanced topics related to VLSI not only, but also all engineering branches in sciences and humanities. It is open for all science. This is an opportunity for students during summer and winter vacations three different states, Tamil Nadu, Telangana, Andhra Pradesh, they are also equally participating as a participants. We will conduct various events under the aegis of Semiconductor Mission. And this VLSI education and they are releasing, or they announced, government of India announced under this mission more than 10 lakhs jobs by next 5 years to educate BTech students in terms of VLSI, chip design, cryptography, network security, blockchain, cyber security, and other allied areas like composite materials, etc. So this is not only meant for ECE, it is meant for every engineering branch as well as sciences. Everybody can participate and learn. That is one point I want to mention. So then 60 and Unnata Bharat Abhiyan MSME, sir, and our students last 2 years participated in IEEE Acton, and recently in Punjab University also they bagged second prize all over India. Last year they got out of 255 entities projects. Our ECE students bagged, and the Department of ECE is having for MSME there are engineering discipline can participate in that, and the other thing is computational and AI related and IoT related. 1 o'clock today will be continued. Thank you one and all. Thank you for your participation.
Now I'd like to invite our Honorable Principal of Maharashtra Engineering College to address the gathering.
Distinguished guests, HODs, faculty members and students, very good morning to one and all. On behalf of management and staff of Maharashtra Engineering College, we welcome the officials of ISVE for VLSI education, and also thank them for sanctioning a zonal center covering one of the 3 largest states of the southern part of India, that is Telangana, AP and Tamil Nadu. Also congratulate Department of ECE for having such facility under the leadership of Dr. Mubal Srinivasrao garu and the coordinators Dr. Ashok and Dr. Sriman. Just now I'm just going through, because I basically from mechanical, a little bit of interdisciplinary knowledge. Okay. So VLSI, a very large scale integration, and suddenly they are also written semiconductor. So that is a buzzword what we are seeing in the paper as well as other technical circles from the last 2-3 years about a lot of improvement on the necessity as far as our country is concerned on semiconductor industry. I think very few people are having monopolizing this area. I think down the lane at the time of Corona, the entire automobile industry came to standstill because of non-availability of the chips also. Because nowadays majority of the automobile, see, they run on these things only, unlike earlier. Okay, so it's a great opportunity, and days back, I'm just going through the LinkedIn. LinkedIn officially posted there are going to be 3 lakh jobs on semiconductor industry by 2026 in India. Okay, so the government is supporting a lot. That's why this is also a government mission to give some kind of a create a talent base, nothing but you students. Okay, is on designing, testing, and all aspects of semiconductor industry through VLSI. So having such kind of a facility at our college is really honor. And only thing is you have to utilize these facilities, because as and when we create such kind of facility, unfortunately the percentage of utilization is less than 5%. Okay, so how many of you know that we have a antenna fabrication facility in your department? Just above canteen. We have a small antenna fabrication facility and test facility also, supporting the ICT. Now, these honorable people also give a lot of inputs on VLSI as well as the semiconductor industry. Any such kind of anything is to be developed or any testing facility is required, definitely the management is kind enough to create such kind of a facility there. And earlier, we have one more robotic facility, that is what Yantra. So whenever we send us any circular, hardly the participation, the faculty are going after you just only to register the course. Clear? So jobs are not only on software like Accenture, Infosys and all, just few people, majority of them are in ECE. So develop the skills on these areas, definitely you will have a very good bright future. Not only job prospects from the research perspective also. So my only request is, unless otherwise if you don't use these, all the facilities extended by the department, it takes a lot of hard work to bringing such great people all the way from Jamshedpur and all to Hyderabad to our college, and giving their experiences and the knowledge sharing and all must be properly utilized by all of us. So I hope take the message in a proper way, and you must come out. Sir, we attended this program, we want this facility, or we want to do this one. And similarly, MSME Business Incubation Center. Okay, so Government of India is giving a lot of funding for that. So far, nearly around 14 lakhs worth of projects are there. And out of 4 projects, 2 are from the students only. Use all the facilities what were available in the college apart from classroom teaching and all. With this, once again thank the officials coming to visiting the MECS and inaugurating the ISVE. Definitely we'll use the facilities here. We'll utilize the services of ISVE. And any such kind of future programs at southern level, you can right away take it for granted. MECS is ready to host. So with this, once again, congratulate the Department of ECE and all the best to all the students. Thank you all.
Now, I would like the officials to forward for the exchange of MOU. we'll have the technical talk. We have the first. The students are requested tea break. The tea will be given in the room. Let us start our technical talk 1. Now, I would like to introduce Dr. Dilip Kumar Yadav, who is currently working as professor at Department of Computer Science and Engineering at NIT Jamshedpur. He received his BTech and MTech from MIT Jamshedpur and PhD in software reliability from Subir Chowdhury School of Quality and Reliability, IIT Kharagpur, in the year 2012. He has research interests in the area of image processing, computer vision, information logic, machine learning, and system optimization. Ability consultant to as well as public sector industries in India. He has supervised 13 PhD theses and more than 250 MTech and MCA theses. He has published 83 research papers in several international journals such as the Supercomputing, Information and Software Technology, International Journal of Performability Engineering, International Journal of System Assurance Engineering and Management, etc. The Pre-India Computer Science and Conferences. He was Secretary of NIMCET 2022, MOE Government of India. He is Associate Editor of International Journal of System Assurance Engineering and Management. He is Secretary of NIMCET 2022 and the current President of ISVE Ranchi. I am honored to welcome you today for this gathering, sir. I welcome Mr. Dilip Kumar, sir, onto the stage for today.
So good. Area of the chip designing. So not very poor. Nowhere we exist in the either the designing of the chip or manufacturing fabrication of the chip. So whatever the mobile or other instrument which is embedded with the chip or supported by the chip you are using, so you see, so hardly find made in India, right? Even you purchase, you see, do not see made in India. You will see sometimes assembled in India. So this is what is the health of our country in the area of the chip designing. You can understand. So that is the big challenge for our country. So this is what is our status, what is the challenge before us. So in this context, so this society objective has been decided, Indian Society for VLSI Education. So earlier this society was very active in Jharkhand around Ranchi, and in 2021 when I take charge as the president of this society, so at that time of the corona, so we try to explore So what are the demand of this society to the people of the India? So, and we have constant it up to the Jharkhand. So this is not a good objectives. So what are the way the people of India may be advantaged from this society? What are the know-how, what are the tools and techniques society was developed by the society? So that should be open and beneficial to the all Indian peoples and also outside the people of the India. So with that objectives, we tried so start so many international conference, workshop, FDP, certificate course, so that so people may be connected, people may be familiar. So through this demand of the country. Unfortunately, so when 2-3 years we expanded it, so the same thing has announced by our honorable prime ministers. So same objectives our country also decided to focus in 22 and 23. And so that is the very big part of our economy. So all peoples are using mobile devices, computing systems, right? And so that demand is not going to be fulfilled by the only South Korea. So what are the things, what are the facts there? So we have all the resources which is required for the chip designing or fabrications. We have technocrat, we have good institutions, right? And we have the people who are manufacturing or fabricating in other country. That people is Indian peoples. So why not that designing or fabrication may be possible at Indian land? So there is no hurdle. Only things was that so there was not a strong initiation in this direction by the government or some of the institutions, premier institutions. So fortunately, in the last year, so both objectives had been coincided. Government of India also focused it. So India semiconductor missions, right? And through this mission, our prime ministers started 2-3 manufacturing industry, fabrication industry of the chip, one in Gujarat and one in near about Guwahati, northeast. So when I think up to next year, 2025, both the setup will start manufacturing of the chip. Then we realize, right? So then actually we will realize, so what are the expectation, what are the economic growth we can achieve through this know-how of this technology, and what are the opportunity for employment to the technical peoples in this area. So here the basic of the chip designing will be covered by other experts. Professor Vijay Nath, he is a proper man of designing. So myself is from computer science background. So we will highlight the computational intelligence. What are the role of computational intelligence for designing, chip fabrications, or applications of this chip technology to the different domain of our domestic and social events. So you are very raw mind. At that moment, if you understand the basic of this computational intelligence, that will give the great foundations to your future endeavor of the research or your life. What is the computational intelligence? How it is created? The computational basic philosophy of computational intelligence is, so how the human mind computes any things. Suppose we have to move next room, how I decide how much time, how much effort we have to take to move the second room nearby, right? We do not go to the measure the second room distance, right? So this room to that next room is the 10 meter or 10.5 meters. We do not go to measure, right? So that is called approximate reasoning or approximate computing. So when we call about the approximate computing, so itself it is involved with the computational intelligence, right? But we are unfortunate that in the computer science area, whatever the programming language we have developed in now, either C programming, C++, Java, or Python, or any other programming languages, so they do not obey the computational intelligence. So that's the objectives. Some programming language should be developed so that computes in the similar fashion as the human mind computes. That maybe also accommodate some approximation value of the data. Then of course that language will be the intelligent language, intelligent computer program. That is our objectives, right? Nowadays, whatever the programming language we use, so that is very hard computing, right? They do not understand the soft computing. If in the program, any of the programming language, if there is suppose x is equal to 2, right? Our program always understand x is equal to 2. They do not understand x is equal to around 2. If x is equal to 1.9, if x is equal to 2.1, 2.05, they do not understand it, x is equal to 2. However, in the real sense, both are same, right? So that is the limitation of a programming language which are using this time. Now things is how this approximate value may be understood by the program. X is equal to around 2, right? So this is the imprecision, vagueness, uncertainty into the data. S is equal to 2 and S is equal to 2.05 or 2.1. Both are same, approx 2. So this should be understood by the program. So there is technology available. Only we have to understand and apply it. So this uncertainty, these approximations may be modeled by the fuzzy logic, fuzzy set, application of fuzzy logic to the data. Then, if the approximate value is going to be understood by the programming language, of course, our program will be intelligent, right? Somehow it will be intelligent. So, for approximation to understand, we have to implement fuzzy logic to our programming language. Once we implement the approximation understanding by the program, Then things is how the knowledge which is embedded in the data, approximate data, that can be utilized, right? That can be learned. So for that, there is another tools. So learning from the data, right? Learning from the data, learning from the examples, right? So there is the learning algorithm. So mathematically we call it neural network, machine learning, deep learning, right? All are learning algorithms, right? So next step is, so we have to implement the learning algorithm, right? Learning from the approximate data. Of course, our intelligence will increase, computational intelligence will increase. And then another thing is, so why we observe the data, why we learn from the data, only objective is to make some decision, right? Make some inquiry, then make satisfied to some query. For that, we are searching to the data, right? If we have to find a pen in this room, right, we look to all the spaces. We search all the spaces, where is the pen? We look to all the images, and in that images we sort the image of the pen, of that pen that is going to be detected, right? So this is the things. So third objective is, we have to make a decision from the uncertain value of the data, and learning methodology based on that data, we have to make some decision. So for making the decisions, so we have to explore some evolutionary algorithm, optimization algorithm, right? So that we can make an optimal decision with the least effort of the resources, means least effort of the data. So that technology, right? For optimization we use genetic algorithm, evolutionary algorithm, right? Different types of the algorithm for the optimization of the, for the making a optimal decision regarding any query of the different domain of the problem. So things are very simple. If we use fuzzy logic, machine learning, and evolutionary computations, means genetic algorithm, maybe, simultaneously, right? Simultaneously, intelligence works in which manner by the human mind, that may be implemented by the mathematical modeling also. So that is the basic of what are the computational intelligence, how it may be learned, how it may be implemented, right, in the engineering domain problem. So only 3 tools we have to understand. We have to learn what is fuzzy logic, what is neural network for the learning algorithm, what is genetic algorithm for optimizing the different decisions, right? So only 3 tools we have to learn. Then we can implement the intelligence in the program or intelligence in the any of the mathematical algorithm. So this is the only way till now for the technocrat. Here, AI/ML will be applied in the chip design, VLSI chip designing or fabrication process, manufacturing process. So there are different manufacturing process that is going to be planned or the fabrication based on the chip design, right? So how that process may be planned so that idle time of the manufacturing may be minimized. If we develop one chip in 1 month, what will be the benefit, right? If in 1 hour we manufacture 1 lakh chips, then that is the useful things, right? So that is the things, what are the demand of the chip by our country, not our world. How we can fulfill that demand by manufacturing from India, right? You can understand, so what will the cost reduction, right? Nowadays, the mobile devices which you purchase, right, good mobile devices, 20,000, 30,000. If it might be available in 2,000, 3,000, what will be the change in the economic understanding of the Indian peoples, right? The poor peoples not able to buy these 20,000, 30,000 mobiles. They cannot utilize the email or like things, YouTube, right? Hardly 20% peoples are enjoying in India, right? But that peoples are enjoying call by call, right? So what will be the change on the of this technology to the Indian people, right? So you can imagine, and this is very simple, very possible by the young peoples of Indian brains, right? So that is our objectives, how we explore this technology throughout the India, and how we can train our peoples, our young minds throughout the country. So in this respect, we started different chapters in the different part of the India. So in that context, this is also one of the zonal office, your institution, this line is the zonal office to make this objective successful. So from this line to the 3 states, Andhra, Tamil Nadu, and this earlier Andhra, Telangana, right? So you are very fortunate. So now you will ignite this area. The people who are here, so that will the governing peoples to explore this technology. So our support will be always to train these peoples so that these people may further concerns to the nearer peoples, right? So that was the objectives. Different algorithm of the machine learning, right, which is being used. So I only highlight this one. Fuzzy logic, you understand? समझ में आ रहा? Okay. So by fuzzy logic, we mathematically model the uncertainty of the data, right? So that I am skipping, otherwise I highlight it here. So suppose, so we try to explain from one simple examples, everybody can understand. So what is the fuzzy set? How it is different from the crisp set? So suppose people tells that he is the long people, right? He is the short people. So how it defines? So they defines people, their height is more than 167 centimeter, that is the long people, right? More than 160 centimeter. And the people who are 160 short people. But what is the reality? 58 centimeter, 155 centimeter, 159 centimeter, even 150 centimeter, they are not short people. And people who are 1 centimeter, 160, 160, they are long people. So this is the only way we define at present. So this rules is not going to be exactly model what are the truth in the data. Who is the long peoples and who is the short peoples, right? So that's why, so we apply the fuzzy logic, right? So in fuzzy logic, fuzzy set, in general set, so there are different members of set. Suppose there is set name is A. In set A, there are members 1, 2, 3, right? Right? Suppose height is a set, height of the people. So height is a set, member is 150 centimeter, 145 centimeter, 160 centimeter, 170 centimeter, 180 centimeters, right? These are the members. So these members has the two possibilities. Either exist in the set or do not exist in the set, right? Suppose 140 centimeter do not exist in the set, right? So if in the normal set we add with each of the members another variable, right, to model the possibility of the existence of that member in that set. What is the possibility that member is the part of that set, right? So then our uncertainty is going to be modeled. So that variable which measures the possibility, that is called membership function. Mathematically we express it mu, membership function. If each member is associated with membership function, then that is the fuzzy set, right? So only this conversion we have to do in the crisp set, normal set, that will convert in the fuzzy set, right? So each member should be associated with a membership function. Membership function is nothing but what is the possibility of that member that is the part of that set. Possibility may be 0, maybe 0.1, 0.2, 0.3, 0.9, 1. 1 means there is 100% possibility that member is the part of that set. If we call membership function is 0.1, means there is a 10% possibility that that member is the part of that set. There is 90% possibility he is not member of that set. So now, anyhow, we have modeled the uncertainty. We have quantify the possibility mathematically of a member to belongs to a set, right? So that is fuzzy logic, right? So there is a mathematics of also fuzzy logic, right? Approximately 2 into multiplied by approximately 4, that is approximately 8. So there is mathematics. We follow that mathematics rules. So automatically that is going to be calculated every time in the calculations, right? There is also fuzzy logic, means data is related, different data is related. So that is the relationship between data. So what is the possibility of the relationship, that is fuzzy relation. Fuzzy relation is also going to be expressed by the fuzzy logic, right? And to mimic the truth of the domain, truth of the data, and knowledge inherent in the knowledgeable peoples, how we can capture the knowledge. So for that, we have to frame the fuzzy rules. If we frame the fuzzy rule, and that rule is going to be assessed by a domain expert, so whatever the knowledge in the domain, we are going to capture it. That is the best way. In the village, illiterate peoples, how calculate, how gain the knowledge? Try to think simple way. They do not go to the internet or book or somewhere. They go outside from home, talk to different peoples who may reply to their query, right? And talking to the different expert, then they decide, oh, this is the truth regarding this answer of this problem, right? So in the same way, that is going to mathematically when model, so fuzzy rule is going to be developed, and that fuzzy rule should be assessed by the domain experts. Of course, what are the knowledge available in the domain experts, that is going to be captured. Then we integrate all the assessment of the fuzzy rule. That is called concatenation of the fuzzy rule, or in simple summation of the fuzzy rules assessment. So what is the integration value of the fuzzy rule? That is also a fuzzy set. That fuzzy set is our output. So that is very hard to understand. Again, we de-fuzzify that output, and again that is the crisp value we can understand. This is the total process of the fuzzy logic when we apply mathematically to any of the database. So by that technology, application of the fuzzy set, we try to mathematically model the uncertainty in the data. Right? Then we come how we can learn from that data. How we can learn from that data. So for that, there are different algorithms. Different algorithm already developed. Now try to understand physically what is this? What is this learning? Right? Suppose how people learn. The 2 years child, how learns? They do not know anything. 2 years old child do not know anything of this process. Right? How that child learns? What is the way of the learning? From the data. Data means all the image are data. Image data. Right? Text data. Audio data. Right? These are the data. So learning is based on the data. Right? 2 years child see the different image. Right? They do not know which image is called by which name. Right? Suppose 2 years child see first time to a cow. Then he asks, what is that image? Somebody tells that image is a cow. They learn. Right? And if several times they make query, what is that image? And all times if it is answered that image is cow, then they learn that this type of the structure of the image is called cow. Right? Similarly, they understand another image. Right? Then they differentiate, this image is not cow, this image is cow. Right? This see the process how it learns. In the same way, we make a model for the learning from the data, right? Either the data is the test data or image data or audio data, right? Philosophy is the same. We have to learn from the data. So for that, there is the learning algorithm. So in the basic of the learning algorithm, there are 2-3 things. What are the input, and corresponding to the input, what is the output, right? See, if there are only 3-4 input and 3-4 output, corresponding output, you easily understand, right, from the relation. If here is 2, here is 6. If here is 4, here is 8. If here is 8, here is 10, right? You make some correlation, right? Okay, outside is being improved by plus 2, right? So that how you understand, right? By matching the input and output, right? And you make a formula that if we add to all the input, we find out the output, right? Means you developed a functions, learning functions. From that functions, now for the unknown data, you will find if x is the input, y is the output, so y is the function of x, and you find out, define what y is equal to function of x in the mathematical equations, right? For any x, then you find y, right? This is the simple things for, right, learning curve. Now same things, if data is huge, suppose 1000 data, 2000 data, human minds cannot calculate. Now y is equal to fx. The same thing we do from the algorithms, right? For the known data, we find out the learning algorithm, learning curve, right? Relation between input data and output data. So we try to find out one of the equation, output is equal to function of input data. Data may be any type of data, audio data, test data, image data, anything data. So that is nothing but that is some learning algorithm, right? When you understand it technically, so for the beginners, you can understand you start from the neural network in the MATLAB programming. Any of the version of the MATLAB program you install, there is the library, big library, right? You download it. So first 100 papers will clarify your basic concept. Then you can understand further any of the machine learning algorithm in the Python. But to physically understand how the algorithm works, so basic fundamentals you can explore from the MATLAB tools. So here is how the machine learning. Now there are some things here. So where we apply the machine learning, where data is available, right? So then, or if data is available, then we use the machine learning, right? So there are, you will hear 3 types of the learning: neural network, machine learning, deep learning. Are you familiar with these 3 terms? Neural network, machine learning, and deep learning, right? What is the difference between 3 learning algorithms? Can you tell? What is the difference? We start from the neural network, right? If the data is very less, so then we apply neural network, no problem, right? So very few layers, or in each layer very few nodes, 4-5 nodes can satisfy our problem. We can find out the learning curve. But if data is very large, 4,000 image, we have to learn, right? There are 4,000 image, right? We have to find out which image is the dog, right? Then, if the image is very high, big image, big value of the image, then we do not apply the neural network. Then we go for the either machine learning or deep learning. Only difference between machine learning and deep learning is both are applied on the big data. How we learn. For learning, some features is going to be assessed. Some features associated with the output. If you are searching in this room a pen, so what is the figure of the pen, what, right? So the attributes belongs to the pen. That attributes is simultaneously assessed every time in the searching. What are the features? What is the length of the pen, right? What is the maybe the diameter, right? What is the color of that pen? These are the features. So only we assess these features throughout the domain, right? And quantify which image satisfies these features, right? If pen is of the blue color, so every time say other color we discard it during the searching. So this is the way, if the big data is given, we have to learn. So in the machine learning, we have to select some features. That features is going to be continuously, iteratively assessed. And that features is manually selected. So when we select manually the features in the learning, that learning is the machine learning. Sometimes it is not possible in the context of the big data. We can search the possible. We make an algorithm such a way, algorithm itself decide the features based on the data. That algorithm is deep learning. This is the basic difference between three learning process, three types of the learning algorithm: machine learning, neural network, machine learning, and deep learning, right? So all these algorithm is based on machine learning algorithm. Now question comes that, sir, if there are some data, we use machine learning. If there is no data, then suppose there are so many failure data. So from the failure data, we learn and make the prediction of the health of the systems, right? If there is no failure, how we know what will the reliability of that systems, right? So there is also some methods, right? Bayesian belief network is the method. So we apply that mathematical algorithm, so, and in that case, where data is very few data or no data, so in that case also we can develop the learning algorithm, right? So that is the category of Bayesian belief network. So from the Bayesian law, we can fulfill that of the objectives in the case of learning also. Machine learning for semiconductor. Now, so what is our objectives? So in case of the semiconductor, so what is the scope of the machine learning. So, new material discovery. Chip is going to be designed. What is the material? Semiconductor material is used for the fabrication, right? Their size very, very small, very large scale, right? So very difficult to fabricate. Manufacturing is very fabricate, right? So, and which type of the material we are going to use, the computing power may be enhanced, right? With device, we manufacture the RAM also. First DDR3 RAM comes, then DDR4, right? So only things is not the circuit, material is going to enhance the performance of the RAM, right? So property of the materials reflects a great extent to the performance improvement of the chip designer, right? So for that, we can utilize machine learning algorithm. In that case, classification is a major category of ML. As a result, classifying semiconductor to different classes is an important subject in this, and the classification is beneficial to discover new material. New material can be discovered, right? So today, all there is tools. So by that tools, right, in the chip designing, so when you put another material, different materials, right, experiment from the software tools, you can find out what is the processing efficiency of the data through that chip for the same circuit, electronic circuit. So that is the one of the challenge that may be satisfied with the application of AI/ML. Next is machine learning is in a smart semiconductor manufacturing. It is important to semiconductor manufacturing to predict yield and understood the impact of process parameters to use it. And predictive maintenance with AI. Predictive maintenance technique helps determine anomalies in operation and identify possible defects. We need to fix them before they fail. So this is very important, predictive maintenance. When we design a chip, right, can we tell? So this chip is a very good quality, they will not fail. You buy a mobile set, right, and you are very happy, this mobile set is of 32,000. This will not fail. You cannot say it like this. Next day you feel there is problem in this mobile. It is better I have missed, I have to buy 3,000-4,000 mobile. Buying 32,000 mobiles, it is fail. What is the design failures? So design failure comes in the initial life, right? So in the initial life, when any product starts its life, so first failure comes the design failure. That is the infant mortality. If there is a design failure in the fabrication or design, and that product is going to develop, that chip has been developed, fabricated, so if initially failure comes, it means there is then flaw, fabrication flaws in the chip. So this information we find out from the failure data, right? Analysis by using ML, AI/ML, right? Of the failure data of the product when it is going used by the customers at the initial phase, right? So that's why based on that data covered by the SIS department of each product, electronics product, So for each product, based on the failure data, warranty time is going to be calculated, estimated. Right? You find out, yeah, sir, this product is warranty time 6 months, sir. No, this mobile warranty time is 1 year, sir. For this product, sir, no warranty, sir. No warranty. You take, there is no warranty. Why this term is used? So this is the predictive maintenance, failure predictions. So that is also by the application of AI and ML. Right? So also some how we extend the life of any electronic product. Right? If it is hardware product, right? So how the life of the electronics product may be enhanced. So for that, we have to find out, based on the failure data of that product, what is the useful life and what is the wear out phase when the maintenance is required. That life from where maintenance is required means useful life has been ended, right? So by predictive maintenance, again useful life is going to be extended, right? So that is also possible, the application of AI. Where we exist, what is our so right, right, manufacturing, fabrication. You see, so this Taiwan is very small country. So only global is not more than Andhra Pradesh. But 5%. What is the population of the world? 65% is going to be fulfilled, means Taiwan. Note that Taiwan 12%. Right. So this how data gives me a strength to explore this object, and that is fabrication is another thing, and so of course US is marketing 47%. Right? They are fabricated, whatever the fabricated by Taiwan, and South Korea 23%, similarly Japan or European Union. Right? No, but low level technocrat or non tech So perhaps I have some points. You see, that survival, right? So read for the of the course in region. So AI and ML is very useful, right? So so in the we have ignite this raw brain, our objectives, our challenge. I now from this time or from this day, you all are a honorable member of our. Your life is very big. Your life is very your useful life has been already gone. I think it's very clear. Always try to deliver more services, technical services, right? No good institution is required. No talent brain is required, right? Forget it. There are so many examples before you. Abul Kalam has not got a degree from IIT, right? He was not a very rich background, right? All peoples can do. All people can learn the chip design technology and work and manufactures very efficiently and leads to the world. So that is also truth. So make your motivation very high and try to learn. In near future, we will put some few weeks, 1 week, 2 weeks training program also. So that from basic you can learn technically and you accelerate your knowledge. Thank you.
Thank you very much, sir, for your enlightened lecture and ignited all of us on this occasion. Now, I request the dignitaries to come over to the dais and sign MOU with CBIT today on this occasion. Welcome, sir. I worked in CBIT in 91 to 95. Dr. V.M. Rao, sir, is the head of the department. occasion, two birds at one shot. The MOU based on Madhusri Engineering College, the message went on across the globe, and now automatically they come forward. That means what is the impact of this semiconductor mission you can understand, and within down the line, within 2 years, definitely you will come forward and you yourself will tell the globe we got an opportunity through this. The private sector in 1981, 79, the first private engineering college under private sector established in Hyderabad in CPIT. Later on, parallel to that, within 6 months, MESR Engineering College under the leadership of Dr. P.V. Narasimhan, Prime Minister of India, college system. That stone is there outside, please check it. And his son, 10 years, established all the way P.V. Rajeshwar Rao, no more. His grandson now, our present chairman. That is the story. Next one is College of Engineering, great legend in technical education. The Department of ET itself 5-story building, in which VLSI fab is also there. Next one, CBIT, MESR, and then three colleges that during 1981. That is the history of these three colleges. Later on, so many joined, that is different story. But everybody is going to Karnataka for pursuing BTech. Then government of India came forward and sanctioned during Boshia's government. The alumni of CBIT, I came to know that in America, California, I think, a colony was established with 300 flats, CBIT colony. It is there, you can inquire. I stunned when I visited California for my IEEE conference. That volunteer came, who was my student, and gave me an opportunity to visit that. Really, I stunned. That is alumina. Sir, please come on to that. Okay.
think it is already good afternoon. Close. All air conditioning, people cannot work. One cabin is so integration used to be word large scale integration internship or same data. And now integration. Of course, now still word is used very large scale, but we don't know extra or extreme large scale integration words will be coming very quickly. And of course, with AI, ML, and all these things, we are going to have a lot of improvement. So, learning from Professor Jadavji's listening, I was very much fascinated. Of course, as he was telling, we have all age of productive, but sharing our experience, of course, it will be always pleasure, and working with young minds. So I will not take much time. I think we will be listening to Vijayanath ji, and our association with VLSI group had been there. I have been chairman for IIT Ranchi for 2 cycles, and we used to have national, international level conferences and very excellent presentations. Many of presentations have come from that we have come. Now it is. I'm very happy that it has come to Hyderabad, and Hyderabad. Anytime on this in this coordination things are required, I am available, and I am happy that at the same time another institute, our CBIT also has been. Both the institutes, I extend my congratulations and all the best wishes. That this topic is very hot. Our learning brains are very much there, and we are here to support it, encourage it. So with that, questions regarding telecom, answer, of course, but I appreciate that in future any things are there. Of course, professors here and your principal staff. Any questions you can ask related, or anyway we can discuss it while our lunch time. But I'll let that topic and real topic we discussed. So thank you very much. Thank you.
Thank you very much, sir. Dr. Vijayanath, sir, was born in Gorakhpur, India in 1906. He received his bachelor's degree in physics and master's degree in electronics from DDU Gorakhpur University, Gorakhpur in 1998, and G gold medalist in 1999. PhD. Dr. Engineering and this institute in 2006. Presently, Design Lab, Department of EC. international contest 2013 in Trivandrum. His is selected in the top 6 organized ISVE and IEEE, etc. Professor in charge of VIT Master Students Chapter ECE. He is Principal Design Course in National Mission Project on Education through ICT MHRD, India, which is coordinated by IIT Kharagpur. He has developed suitable pedagogical methods for in e-learning for funded by Government of India, such as design of in VLSI funded by DST New Delhi and DRDL Hyderabad. Design of ultra-low CMOS temperature funded by Respond ISRO, Bangalore. He has conducted several short-term courses such as summer system design, IIT University, etc. Have got jobs in core companies. Many faculties have started research and received the grant from government funding agencies. Industry and supported by TI embedded system design using for cost microsystems and IoT, published by ISVE ranking. It is approved by ISSN Government of India and ISSN Paris. SCI, etc. If we use the dais.
Thanks for a nice introduction. Very good afternoon, respected principal of the Matusi College of Engineering, Hyderabad, respected president of ISVE Ranchi, our senior colleague and you can say as a guide, Sri K.K. Thakur sir, and principal study of this department in Inauguration Communication Engineering, Sri Mr. Naflar Srinivasa Rao sir, and Arindam Rahman and other faculty members of this institute, and my dear students. Now it's a great pleasure that we have going ahead to strengthen our country because, as you know, all the type of problems you have to solve by our seniors, as Dr. Mathur told, what is our contribution in this thing and how you can strengthen our country. For that, we have to take the lead. Okay, look, this is your country. You have utilizing the name and fame of this country. Then you work for the country. Okay, so how will we start this journey? Let us see from
to 1. You have understand the term of VLSI 0 to 1. We have start from 0 and going to 1. Without applying, without investing huge money, we are going to earn huge money. Okay, because these are my young child. When you have prepared in VLSI, integration guarantee of 50 to 3 years, he will be stakeholder. Okay, today he doesn't know anything, ABCD, but he will be tomorrow his stakeholder. He has a key and he wants to work on that. Okay, now this initiative we have working in the 2015. Before 2015, also working in VLSI design and Khalil Rahman and others. They have come with her as a young, and his guide Dr. Rajesh is also working with us. In that terms, we have developed so. Understand? In 124 billion, 60% people using the mobile. Is it? You understand what is the contribution of development? Zero. Your 60% money, 144 billion of 60% multiplied by 10,000 to 20,000. Understand how much money have to invest, how to get to other. Okay, so you have to be prepared yourself, and government has taken the initiative. The first thing we should regard is manpower. Okay, so if manpower will be there, if our young child will be trained, then they will be directly set up in that boundary. Okay, as you have to got in England and other resources, in 2025 we have more than this young youth should be required. It should be applied in their boundary line. Okay, so for that one, from today you have to start the preparation. Okay, you have to this courses in your graduation level. Is it? Because all things what you are teaching, that is not up to date of the market. Okay, what is the need of the market? We try to do very product. That's why we have come from Ranchi to here to facilitate you. Okay, so it's a great pleasure. We have our senior executive officer, D.K. Yadav sir, have with us. Has a long association with D.K. Thakur sir. In the 2 terms, I was secretary of this IG. He was the chairman, and a lot of initiatives have to be taken. IG University in Jharkhand, and I think more than 10 focus groups have been published from microelectronics and computer system, microelectronics, circuit and communication system. All are published by students. Okay, there your papers of the National certificate is also there. Maybe. Okay, these are several times that your sessions here, committee members, panel advisors and others. Okay, so we have working not from today, from long back, but we are at a, from in the ground. Okay, so you have seen, we can say his mind is very young. His mind is very young. Okay, he use water, clean water, use require the continuous
Bharat 2047. Okay, our country have to be independent in 1947. Get our country be what is objective? Formulate ISM. What we're going. presenters. US, China, and other countries. Now they are fighting. You are my friend, you are my friend. Okay, China is telling to Taiwan, you are my friend. So you have start your work from there. Okay. So now the VLSI declare
We are highly thankful to you, sir, for granting a job in Maharashtra. Immediately, CBI also joined. So we will do our level best. This is a promise to educate our. That is our promise. Time to felicitate our delegates and experts. I request Yadav, please come
Madam. Myself, Dr. Ashok Kumar, Assistant Professor, EC Department, Madhurti Engineering College. And, welcome for the vote of thanks. The program is started with the lighting of lamps. All dignitaries and principals are joined with the lighting of lamps. And after that, the Madam Sribala Madam is given the welcome address with introduction of guest of honor. After that, Dr. Nukala Srinivasarao sir, head of the department, and who is the zonal coordinator for the ISVE. Sir is stressed the jobs of semiconductor industry and also introduced the department of ECE from inception. After that, Principal sir is given the importance of the program and semiconductor industry, how the jobs are launching for next 20 years. The program is went after that signing of MOUs from both ends, ISVE Ranchi as well as Matrushri Engineering College. After that, the Professor Dr. K. Yadav, sir, President ISVE, shared knowledge on AML in semiconductor industry India, and also sir also explained computations, and sir also enlightened the statistics of chip fabrication industry at different countries. In between, the professor of CBIT is joined hands with the ISVE Ranchi and done the MOU with ISVE Ranchi and CBIT College at Matrushri Engineering College. And in this regard, Matrushri Engineering, the program after the Dr. KK sir, Thakur sir ignited the young minds with his work experience from the trunk calls to the mobile phone calls. So how the calls are in olden days, now how the people are using for the mobile calls. So after that, the Dr. Vijayanath sir, General Chair, ISVE, given the key points of Viksit Bharat 2K47 under the India Semiconductor Mission ISM, and also sir is recalled the statement of G20, that is 1 Earth and 1 family, given by the Prime Minister Modi. In this lecture, I also extend the SARS lecture. There is always a gap between the robo human mind. So always you need not to depend getting the new job for the young mind. Thank you, sir, if you accept this. And furthermore, we as Matrushri College, we thanks to the guest of honors today and Principal sir and Matrushri Engineering Society, Matrushri Education Society, and Department of Matrushri Engineering Colleges, and audio video team, and YouTube team, and teaching and non-teaching staff. We give the thanks for the audience who joined online and offline, and also we extend the thanks to one and all who involved directly and non-directly in this to make the grand success. Thank you.
Now I request everyone to Thank you everyone for attending the session. I request all the students to disperse and continue with your classwork.